You're in the Waterloop.
Waterloop. Welcome to Waterloop, the nonprofit news outlet exploring solutions for sustainability in water. I'm the host, Travis Loop. Odor control and overflow prevention are critical yet often overlooked challenges for wastewater utilities, especially as urban areas expand and climate impacts intensify. In this episode, Ryan Powers of the Wager Company explains how a family business that started in marine ventilation is now helping communities solve complex sewer problems on land. He discusses why traditional chemical and carbon-based systems are costly, maintenance-heavy, and environmentally burdensome ways to fight the problems. Powers also highlights the benefits of passive, low-maintenance designs that eliminate odors and prevent inflow and overflow without electricity or chemicals. Before starting the conversation, I want to share a minute more about this episode's sponsor, Wager. If you value Waterloop content, please thank the sponsors like Wager that make it possible. Tired of complaints about wastewater odors or floods overwhelming your system? Wager's passive solutions deliver simple, sustainable results. Their odor control systems, like the reliable 450 model, neutralize hydrogen sulfide in residential lift stations and small sites without electricity or constant maintenance. Powder-coated grass green to blend seamlessly, they keep communities happy and utilities cost-efficient, reducing reliance on expensive chemicals. Built on 90 years of expertise, Wager's inflow and overflow valves, like the proven 1700 model, block floodwater intrusion and prevent sewage spills, safeguarding waterways and avoiding costly fines. From local neighborhoods to global markets like Dubai and Canada, Wager's low-maintenance, passive designs protect infrastructure and the environment with unmatched reliability. Learn more at wagerusa.com.
I'm always amazed a little bit that after decades and decades and decades of dealing with odors, that there's still an issue out there.
Yeah.
Could you talk about the issue of odors, especially in like the smaller scale wastewater settings or lift stations?
Well, I think the main thing is a lot of these lift stations are put into residential locations. Typically, they were engineered and put in place before a home or neighborhood is put there. And so over time, you're going to get odor complaints from that. Your huge sewer systems, sewer treatment plants are typically further out, and they don't really have that issue. But when you have a lift station, it's typically close to a neighborhood or school. And what this does is that, one, you'll get odor complaints, but it also lowers the value of their home, if they're going to have odor nearby. So that's the main reason why you get a lot of complaints.
What causes the odor at these lift stations? Kind of take me inside it from a structural point perspective. What does it look like and how does that happen?
Yeah, well, it's just H2S, hydrogen sulfide gas that comes off of waste, So you have the solids and liquids, and then you also have gas. And so that gas has to go somewhere, and it usually takes the path of least resistance. So it will go wherever it can escape, it will. And so that's where we kind of step in, is we kind of treat that air before it goes out into the atmosphere and affects the surrounding area.
Yeah. And what's the setup at a lift station, when it comes to up, down, around, that's kind of letting that escape, if you will?
Yeah. Well, they're all a little different. And I think that's what's unique about each station is designed for its actual location. And they're all a little different. So,
that's really a challenge then, right?
It's kind of a challenge, yeah, because you might have a situation in one area that's completely different than the other, and different cities also. Do they address odor control differently in every city? So that's where we're kind of, I think, one of the first to address odor control on a smaller scale than trying to go after the large treatment plants. We don't really do that. We are trying to address the small odor complaint issues in residential or commercial locations.
Before we dive into that further, tell me how utilities typically do deal with odors then, maybe at the bigger scale. I'm very curious about that.
Well, there are solutions out there. They're usually very expensive solutions, where they might use like chemical feed solutions, or they might use like a carbon based product. Now, there's two reasons why these products are inferior. Is the carbon is really becomes toxic itself. You can't throw that away in a landfill or whatnot. There's a lot of cleanup programs to remove that carbon, where they need to be vacuumed out of, say, a big 50-pound drum of carbon, to address the odor. But it creates more of a maintenance issue, because you have to have someone go out and service that. And then you have to figure out what to do with that carbon once it's expired. And so there's the issue with that. And then the chemical feed is very effective, but it's very expensive. And so what we do is we actually do work with a lot of those situations where chemical feed is necessary, because it is you might have a situation where the H2S, the parts per million, are so high in the concentration of gas is so high that there's really no solution other than to really combat that H2S as quickly as possible, so it doesn't damage the sewer lines and stuff. So we use our odor control system almost a little bit further down the line as a polisher to kind of reduce whatever else that chemical feed isn't getting, or we can reduce the amount of chemical feed used in on a line to save money.
Yeah. Is there a trend in the industry or a desire in the utility space to move away from chemicals where possible?
I think so. I mean, just being environmental friendly, I think it's beneficial. Not just the cost, but if you can find a solution that doesn't require using chemicals, is always a good thing.
Because of the environmental threat, if you will, but also then you've got to remove those chemicals sometime too, right? So there's like the cost, and then
yes, yeah.
Can you talk more about that a little?
Well, I think it's just a matter of using, in some circumstances, they will use water as instead of chemical to flush the sewer lines, but you might have a tremendous amount of water being used, that instead of chemicals. But it's just a matter of the utilities, what they prefer to use. And we're trying to find an easy solution for H2S, but that doesn't require any electric or any, all of our systems are passive. So we use a very simple solution for odor control.
Yeah, sure.
No.
You mentioned how these lift stations especially are in so many different kind of settings and circumstances. So they're going to be different sizes and configurations.
Right.
How important is it to figure out a solution that's the right size and the right specification?
For the lift station?
Yeah. Could you talk about that? Because I know that's something we talked about before, right? It's like engineering things that are too small or not the right configuration, and just kind of why that's all a challenge.
Well, typically lift stations are put at low spots, at a low prone area, and they pump up the sewage uphill. So that's why it's kind of like a lift station that goes up to where the high point, and then gravity will then take it down to a sewer treatment plant. So inside these lift stations are pumps, and they're usually two pumps, and they pump gallons per minute of sewage, and in that the byproduct is H2S gas. So right there is where we treat the gas, and then the sewer pumps pump that sewage up to the next station. So it depends. Your answer is it's hard to answer that, because it depends on on the size of this of the what's around there. If you have a high population area, it's probably going to be a larger lift station, treating that area.
Yeah. Connected to the odors are, inflow, overflow, right?
Yeah.
Could you talk about the inflow side of that? What are inflow events? Or, educate the audience here a little bit
Yeah.
about these and why, what problems they cause.
Well, for inflow, what we have is, and it really is not necessarily odor. We're allowing fresh air back into the sewer lines. There's kind of creates a equal pressure, so to speak, into the sewer lines. Um, uh, so we have a valve that will allow for that fresh air in, but prevents any other debris or water from going into the sewer lines. If you have too much water, say in a flood prone situation, if you have a flood event, that water is fine. It will go into the sewer lines. But over time, what you're going to do is you're going to have a rush of water go into the sewer treatment plant that all that has to be treated.
Yeah.
Whether it's sewage or water. So you're putting stress on the whole system. So if you can prevent that, you're actually making it efficient throughout the whole sewer line.
Yeah. And then kind of tell me that solution piece then.
So what we have is my great grandfather invented, as I said earlier, he invented a inverted vent check valve. This was typically used on board a ship to prevent water, from getting into the hull of the ship and possibly submerging the ship.
Not a good thing. Yeah.
Yeah. So we had an engineer see that valve and said, you know what, this would be great for outfall sewer lines, and so we installed it on a line and it works great. What you typically see out on like a greenway, you might have seen it where it says 20-foot pipe that has like a candy cane gooseneck pipe on it, and with nothing filtering that air. And that's okay, but one, it doesn't look very attractive, a huge pipe sticking out of the ground. Two, if there is like a flood situation sometimes, or wind or whatever, that could get knocked down, our valve will eliminate that pipe or reduce it down dramatically so it sits lower, so you don't have to worry about that. But it does the job of preventing that flood water from getting into the sewer lines or debris. Debris can damage, do a lot of damage. We have a very small unit that does the exact same thing, but protects grinder pumps from getting damaged. And we had an instance in one of the hurricanes in the Gulf that wiped out, I think, 3,500 grinder pumps, or 35,000. I can't remember exactly. But FEMA stepped in, and we're one of the solutions for a lot of these grinder pumps to protect them.
Yeah. The other challenge is the overflow scenario,
Yeah.
right? That can happen at these lift stations. Could you talk about what that is, what happens with that?
Right. Well, if there's a situation where you have a stress on the system, you might have an overflow or sewage that backs up. If there's like a clog, for example, same as in your bathroom, if it clogs and that toilet overflows, you have a major problem.
Absolutely.
So same situation. And a city or a municipality can get major fines with outflow of sewage. One, it's an environmental hazard, but two, it's something that could affect the entire region, so down the line. So we have a valve that will also protect that sewage from coming out. It's an overflow valve, so we prevent overflow sewage from coming out.
Talk about this idea of passive systems.
Okay.
Right? Like, I guess overall, and then you can talk about how your solutions provide that. But what is a passive system when it comes to these solutions? You've touched on it, but yeah.
Right. Passive systems don't require any electricity or any fans or any means of drawing that air from one to the other. So what we have is all of our systems run typically off gravity or airflow. So there's no electric needed for our systems to work. Inside our system is an engineered media. And what happens is that when that H2S gas reaches our media canister, inside there's pellets of media. And upon immediate contact, there's a chemical reaction that happens. And what happens is that the chemie absorbs that H2S gas and changes the molecules of H2S into a non-toxic, odorless air.
Wow.
Yeah.
And then does it hold that, or that just makes that chemistry happen and then it just continues on?
Instantly, yeah.
So it's not something you have to service necessarily either.
Right. Well, over time, you're going to have a situation where that media begins to break down. And what we do is we size each unit to get at least 2 years before you have to go service it. And when it is time to service our units, we make it very, very simple. We want to make sure that all of our systems are very easy for maintenance. And it's very simple. It's just opening up the lid of the system and replacing it with a new canister, which we provide. A new canister of media, and then you'll get another 2 years before you really have to go out and service that unit.
So I guess with all the challenges that utilities have, if they can have passive systems, use less energy, spend less money, less chemicals, less money, less people coming to work on it, less money, it's like...
Yes. Yeah. But that's the goal, is to try to have the best system, but at a cost that is affordable for a small community to have. Yeah.
That's a great point, right?
Yeah.
There's the smallest of systems have these lift stations and have to come up with solutions.
Right. And, a lot of these locations, as I mentioned before, they might have been out in rural areas before, but now they're really becoming populated areas where originally there wasn't electric or wasn't any way or means to address that. So we're kind of like leapfrogging that and putting our systems in to these areas that are helping the community around it. And we pride ourselves in making our products at least look attractive for the situation that they're in. We powder coat all of our systems in a grass green finish and epoxy coat them. And we've had a tremendous amount of success stories with people that couldn't even go out on their front porch and enjoy their house, to where now they can go outside and enjoy the area around them.
Ryan, thank you so much.
Yeah, thank you very much for having me.
Thanks for listening. If you want to support Waterloop's ongoing exploration of water solutions, subscribe on YouTube, rate and review the podcast on Spotify and Apple, follow us on social media at The Waterloop, and sign up for email updates at waterloop.org.
You're in the Waterloop.